For 1.2 notes domain and range, we're going to identify domain and range for relations. The set of all inputs or x's is known as the domain, and the set of all outputs or the y values is known as the range. We're always going to list domain and range from least to greatest without repeating values. So even if a 9 shows up multiple times in the domain, we're only going to write it down once. So here we have a couple of relations like we practiced in our previous section with tables and mapping diagrams and ordered pairs. And we want to just list out domain and range as numbers. So for the domain, we look at the x values. And we want to go least to greatest. So 0 would be the least, followed by 1. And even though 1 repeats, we only need to write it down one time. And same thing with the 3, it repeats, we just need it in our list once. And we just use the brackets to help close the set. For the range, we have -3 would be the very first number, it's the least in the group, followed by -2, 1, 4, and 5. With a mapping diagram, remember the x's are your inputs on the left, and your y's are your outputs on the right. So for the domain, the numbers are already in order from least to greatest. We just need to copy them into our set list, closed in brackets. And the same thing with our range. The y values are already listed from least to greatest in the mapping diagram. We'll just copy them into our set list. For ordered pairs, you need to remember that x and y create an ordered pair. So all of the first numbers are the x's, and all of the second numbers create the y's. And now we're going to split them apart. The domain needs to be the x values from least to greatest. So it will go 1, 2, 3, 4, and 5. And our range values would also go least to greatest as y's. Looks like -7 is the least, followed by -5, 4, 6, and 8. And you can go ahead and close that set. So that's to get us started on domain and range, picking out the x's and y's from one of our relation displays. We can also work on domain and range with graphs. So with the domain, when we're reading a graph, to find the x values it includes, we want to work from left to right. For the range, we want to work top to bottom or bottom to top. Bottom to top would make more sense because you're talking about your lowest, your least number up to your highest number. So there's two types of graphs that you're going to be asked to use to find domain and range. First, we have the discrete graphs. That's where the points are disconnected. I don't have a way to connect these points. I wasn't given any lines with it. So if points are disconnected, it's discrete. And we need to know, where do those points sit? Where are they located on the coordinate plane? So that you can come up with the domain, the x's, and the range, which are the y's. So there's different ways you could go about this. You could just look at the points. So if we started all the way to the left, we would need to know what is the x value that that point lines up with, which would be -2. The next point, as we move to the right, would have an x value of -1. Our third point has an x value at the origin, so 0. And we continue to keep moving. We have a new x value at 2 and another x value to get the last point at 5. Now, if that was difficult for you to read going across the graph, then the next option would be what we practiced in our pre-algebra unit and even in 1.1 is write out the ordered pairs of all the points. So if I start at the bottom here, I have -2 would be the x and -3 would be the y. The next point is sitting at -1, +4, because remember we always write x then y. So the third point is sitting at 0 for x, -2 for y. Then we've got 2, 4, and 5, -1. So if it's easier for you to write out all the ordered pairs and then pick out your domain and range, there's absolutely nothing wrong with that. So now for range, we want to go least to greatest Y's. Feel free to just kind of read the graph from the bottom to the top or use the ordered pairs. But we would have -3, -2, -1, and 4. Notice that 4 showed up twice, but we only need to write it down one time in our set list. A continuous graph is where all the points of the graph are connected. So if you look at this circle, there's multiple points sitting on the circle. There's actually infinitely many. We could make points on this circle all day long. The point you see in the middle of the graph is not actually a point of the graph. It's just called the center of the circle. So I would just kind of scribble that out or maybe color the circle in so that you don't get confused. So when we have continuous graphs, we have to use inequalities for intervals of the values the graph sits between. So hopefully you remember we have symbols like less than, symbols like greater than, and then we've also got greater than equal to and less than equal to. That little bar at the bottom just means equal to. Not every answer of your continuous domain and range are going to look the exact same, but if you have a completely enclosed shape, so what I mean by that is the circle connects all the points together. There's no arrows to make the graph go a different direction and continue on. So if it's completely enclosed, you're going to set up your domain X, your range Y, because we need to use the variables with our inequalities, and their compound inequalities sitting between two numbers. So the lowest number, which we haven't filled in yet, that'll go here. The lowest number is less than other x's of the graph, which are less than the highest number on the graph as far as the x coordinates. So let me clean this up a little bit. Again, just ignore that point sitting in the middle of the circle. It's just to show you where the center of the circle is. So we're going to kind of create a fence around the circle. The farthest out it goes to the left, and the farthest out it goes to the right. We're going to use that to help us with the domain. So the farthest left the graph hits is at -5. We have that point at -5 from the x-axis. And the furthest right it goes would be at +1. So it goes all the way from -5 to 1. It has points like when x is -4, it has a point on the circle. When x is -2, it has a point on the circle. But there's all the points in between as well. And we don't want to have to list out all of those numbers. It's a continuous list that would never end. So instead we say the x's fall between -5 and 1. And the inequality would be the less than or equal to for both sides because we're saying -5 is less than or equal to all the other x's of the graph, which are less than or equal to the 1. You could also read it like -5 is less than or equal to 1 because that makes sense. I should not see any greater than equal to symbols when you're talking about a compound inequality for domain and range. Let's try this with the y's. We're going to create that kind of fencing system again. So we want to go from the bottom, which is at -1 on the y-axis, up to the top, which is at +5. So the y's go as low as -1 and as high as +5. But again, using the less than or equal to symbols, we finish that inequality. So with an enclosed shape like a circle, you have the compound inequalities like you see here for domain and range. But the next graph, which is still continuous because it's connecting multiple points on the same curve, all of these are different points sitting on the curve. Okay, we don't have compound inequalities necessarily. We need to figure out how to write those inequalities then if it doesn't close up the shape. Let's start with domain. These arrows at the ends of the graph are pointing both left and up. And this arrow is pointing both right and up. So the graph is going to continue to stretch out horizontally and stretch up vertically. If you can continue the graph to the left and the right, it never ends. we say that all real numbers can be used. So in this case, if we're talking left to right, that's for the x's, the domain. And we could do that with range if the graph always went up and down, but this graph can only continue upward. It does not continue downward. It has a stopping point at -4 when you look at the y value. So that means -4 is the kind of significant number to refer to. It's our reference number for the inequality. And we want to compare that to all the other y's on the graph if we're talking range. If we say all real numbers, like our domain problem, we don't really need to specify our variable. You could say x belongs to all real numbers, but the y is either down at -4 or above it. It keeps going up from -4. So that would mean all of the y's are greater than or equal to the -4. Let's say that graph was flipped upside down. So if we just make a quick chart here, let's say this is sitting at 6 and the graph flips upside down. And this is just a quick extra example. If you want to fill it in, you can. So the domain is still all real numbers because this curve is going to keep going to the left. The arrow is telling me it's going to never stop moving left, and it's never going to stop moving right. The graph continues. But for the range, it starts at the top. It has a stopping point at 6. So we want to compare the graph to the 6. The original red graph from the top point moves down. So it goes from 6 to 5 to 4 to 3 to 2 to 1 and so on. It never stops moving down. So all of the other points are underneath the 6 or less than and equal to 6. The more you practice this continuous graph with inequalities, the easier it will get. A linear graph, a straight line, never ends in any direction, so we see that in this example. Kind of like the domain of the last two graphs we discussed, not kind of, it is, it's all real numbers because the graph never stops moving left, it'll keep going, and it never stops moving right, it'll keep going. And this graph also just keeps moving down, 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 and up, 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 up. So the range is also all real numbers. This would be a continuous graph because all of the points of the line are connected by the line, and we could be drawing points all day long. The last part of this lesson is going to use some real-world examples, so that will be in its own separate video. Take your time to kind of split this part of the unit up. If you want to go back to the basics of looking at relations and listing out domain and range, that's a good way to start. If you're ready to move on from that, you want to start working on the graphs that we discussed in this video. And then once you feel comfortable with the graphs, especially these continuous graphs, it would be good to go ahead and move into the real world examples